Objective. After reviewing this video, you will be able to identify and describe polyatomic ions, name ionic compounds, write ionic compounds when given the name.
Vocabulary.
Ionic bonds. Transfer of electrons from one atom to another occurs between a metal and a nonmetal. There has to be an electronegativity difference of more than 2 between the two ions. Polyatomic ions. Certain elements like to be found together. That causes them to behave like one element. Some more commonly used polyatomic ions are nitrate, sulfate, hydroxide, carbonate, phosphate. Again, these are the more commonly used polyatomic ions, and we'll get more practice in class using them, so don't freak out. Did you know ionic bonds have an extremely high melting point? Even with the use of a Bunsen burner, we would still have trouble melting most ionic compounds. It requires a massive amount of energy to break an ionic bond, so much that a Bunsen burner cannot add enough energy. Naming ionic compounds. For example, we'll use calcium chloride. So, the beginning, the cation, will be named. You just name the element. With the anion, the negative ion, you take the chlorine, you drop the ending, and add IDE. So another example, we'll use Mg, which we name the cation, which will be magnesium. Then we name the ion, which in this case is a polyatomic ion. And the polyatomic ion name for SO4 is sulfate. So the name is magnesium sulfate. Again, when naming ionic compounds, it's between a metal and a nonmetal. The metal is named first, the nonmetal is named after that. So for the ending ion, if it is an element, drop the ending and add IDE. If it is a polyatomic ion, just use that ending. Writing ionic compounds. Make sure the cation goes first, so your positive ion or your metal will go first. Make sure the charges of all your atoms balance, so the overall net charge should add up to 0. If you have more than one polyatomic ion, you must put the ion in parentheses. So for example, if I had 2 nitrate polyatomic ions, I would put the NO3 in parentheses and a little subscript 2 to show that I had 2 NO3s. So we do not need to worry about prefixes when we're writing about ionic compounds. They'll come into play when we talk about naming covalent compounds. So remember, the cation goes first, then your anion. Crisscross! We're going to use the crisscross method to write the chemical formula for calcium chloride. So first off, we need to write out the symbols. So calcium, which is Ca, and chloride is just chlorine, so we'll write Cl. Next, we need to write the charges. So calcium is a 2+ because it is found in group 2. Chlorine, which is found in group 17, would form a -1 ion. Now, we have to crisscross! And so what that does is the charge of one becomes the number of atoms for the other. So the 2 plus is the charge, and that's going to become the number of atoms for the chlorine. And the minus 1 charge for the chlorine will now become the number for calcium. And so the Cl becomes a 2, and that minus 1 for calcium becomes a 1. And so I'm going to bring them together, and you can drop the 1 and just write CaCl2. Naming ionic compounds for transition metals. Used for transition metals and the elements lead and tin, you need to include Roman numerals to indicate the charge on the positive ion or the metal. The exceptions are for zinc, which is always a 2 plus, and Ag, which is silver, which is always a 1 plus. Now, along the bottom are your different Roman numerals. We have 1, which is the I, 2 I's is 2, the 3 I's is 3, and then the IV is 4. And the Roman numeral for 5 is just a V. So that'll be up here, right here. So naming ionic compounds for transition metals, we're going to continue. We're going to have the name iron 3 oxide. So let's write out the iron 3 oxide. So iron will be Fe. Oxide is just oxygen. Remember, with oxygen you drop the ending and write IDE. And then the 3 Roman numeral, it represents the charge for the iron. And so, well, let's write down the Fe down below. Then we'll write down the O for the oxygen. Now remember, the charge for the Fe is represented with the Roman numeral of 3. So we'll write the 3 plus for the charge of the Fe. And oxygen, being in group 16, wants to form a 2 minus ion. Okay, because it wants to gain 2 electrons. Now remember, crisscross! So the charge of one will become the number of atoms for the other. So the 3 plus moves down to the bottom right next to the oxygen, and the 2 minus will become 2 for the number of atoms of iron. And so it becomes Fe2O3. Naming hydrates. Simple ionic compounds that have absorbed water. Anhydrous has no absorbed water. To name hydrates, simply include the number of water molecules. So we'll have 2 examples. The first one, CuSO4 5H2O. That will be named CuSO4 as copper 2 sulfate, and then when you have 5 H2O molecules, it'll become pentahydrate, because 5 means penta. Now, if you want to go over prefixes more in depth, go to the covalent naming podcast. Now, the MgSO4. So Mg is magnesium, SO4 is sulfate. So we'll have magnesium sulfate, and then we have 7H2O. The 7 means hepta, so it becomes heptahydrate, and so putting that all together becomes magnesium sulfate heptahydrate. So now let's do some practice naming ionic bonds. So the first example, AlBr3. The Al is aluminum, Br is bromine, but you drop the ending and put IDE, so it becomes aluminum bromide. CaO. Ca is calcium, O is oxygen, but you drop the ending and put IDE, so it becomes calcium oxide. Next, we have NH4NO3. The NH4 is ammonium, and the NO3 is nitrate, so it becomes ammonium nitrate. And then the last one is FeCl3. Fe is iron, Cl3 is chlorine, drop the ending, put IDE, and that 3 in the subscript of the chlorine would actually be the charge of the iron, because you're working backwards from your crisscross, and so it becomes iron 3 chloride.